We're in section 3.6, which is talking about parallel lines in the coordinate plane. And you're going to notice that through most of the chapters that we look at, there's always a section or two that talk about in a coordinate plane. And there's a lot of things to know when we're talking about coordinate geometry. And we're talking about parallel lines. And in a coordinate plane, I'll tell you that last year in algebra, you guys did a lot of stuff talking about parallel lines within and looking at some ordered pairs and in a coordinate plane and with graphing lines that were parallel. And what are some things that we remember about parallel lines on a coordinate plane, on graph paper and graphing?
Well, they never intersect.
They never intersect.
Okay. Well, I'm just kind of looking at your first question. Probably has something to do with slope.
It does. What do you remember about the slope of?
Okay, well, can we just talk about what slope is first?
Let's talk about slope.
Then I'll throw in the parallel. And the fact that you're talking about here, so we're not going to be probably talking about like all the different special angle pairs since it's dealing with
not talking about special angle pairs.
Okay, all right. So what I remember about slope from last year, even the year before, slope was talking about how steep a line was. I'm just going to brainstorm. Is that cool?
Uh-huh.
Okay, so steepness. A lot of times it's that rise over run.
Mm-hmm.
And there was a variable we used for slope.
What was that variable?
M. So M being the slope is the rise over run.
Uh-huh.
And essentially what the rise is talking about is kind of what's changing in the Y, the vertically. And then the change in the X. What's the little triangle that you just did?
Oh, that's a delta symbol. That's representing the change in something.
Okay.
You'll see that sometimes in science.
Okay.
You'll see that sometimes in math,
like,
too.
Triangle and Y, triangle and X.
Sorry, that's my abbreviation. But
No,
yeah.
I know exactly what you're talking about. I'm just thinking.
They may not know. That's probably a good call.
No, but that means delta or the change in it. So changing, basically when you're trying to find the change in something, it's kind of like the difference.
Uh-huh. You guys may remember this.
Y2 minus Y1 over X2 minus X1. So that's the formula that we can use if we have some ordered pairs like you said.
Yes. Okay, so let's think back to what we did talk about, though.
Okay.
When we were talking about lines being lines being parallel.
Uh-huh.
Last year, what did we learn about their slopes?
They ended up being the same.
Exactly. So just to kind of lead us into what we're going to be talking about here in just a minute. Okay. Now, let's talk about how to find slope. We said we could either do rise over run, or you could do change in Y over change in X.
Okay.
So looking at this kind of picture that I have here, I've got it on a coordinate plane. It's a line.
Mm-hmm.
Not talking about parallels yet, just making sure we know how to find slope first.
Yeah, because that's kind of essential.
It's essential to what we're going to be doing today. And let's go ahead and I've got points on this line. There are other points that are on this line, but let's go with the points that are marked.
And how many points do you need to find the slope of a line?
Just 2.
2, okay.
Any 2 points. These are not the only 2 I could have chosen.
Yeah.
But because they're marked, I'm guessing that that's probably what your teacher would want you to use, right?
Yeah.
Okay.
Of course.
So let's go ahead and let's label these points. What do you know about this point up here?
That ordered pair is 2, 4?
2, 4. Absolutely. And what about this ordered pair our point that's marked down here? What would that ordered pair be?
So that'd be 1 to the left 4, -4, and down 2. So -2.
Great. Now, we talked about really a couple ways you could find this. We could talk about rise and run, right?
Okay.
So I could say, okay, what's the rise to get from one point to the next? How many am I rising?
Okay.
And then how many am I running?
Okay.
Okay. So let's look at just the rise.
So can I just count?
You could just count.
Okay, so up 1, 2, 3, 4, 5, 6. So it went up 6.
Up 6. I'm going to put a little positive 6.
Uh-huh.
And my run.
1, 2, 3, 4, 5, 6 to the right. So that'd be another positive. So my rise to my run. So if I compare rise is 6 over my run, which is 6, and then simplify it, right?
Uh-huh.
And
Which
that
would
would
give
just
us
simplify to 1.
to 1.
So that's my slope.
So that's one way we could find it.
Okay.
The other way we mentioned was the formula.
Okay.
Okay, so let's go ahead and let's take a look at the slope formula. We said that slope formula again was that y2 minus y1 over x2 minus x1. Now, does it matter which ordered pair we call our first ordered pair and which one we call our second ordered pair?
Well, I remember when we had this, like with distance and midpoint formulas, it didn't really matter.
And it doesn't really matter here
as long as
either.
I'm probably consistent. Like if I start with the bottom left one as my like y at my x2 y2, then I need to kind of be consistent.
Okay.
Okay, so if that, let's say -2 is my y2.
Okay, so I'm going to call this my second ordered pair and this one my first ordered pair, just to keep track. That's
Okay.
yellow. I don't know if you guys can see that or not. Okay.
So then y2 is -2 minus my y1, which is 4,
Uh-huh.
over my x2 is -4 minus my x1, which is 2.
And if we go ahead and do that math, we know that fraction bar, do everything on the top and then everything on the bottom first, and then simplify the fraction.
-6 over -6, which would still simplify to 1, which is what we got when we just counted.
Exactly.
Okay.
Now, counting is a nice option when it's already graphed.
Yes.
And when it's not very hard to count them.
Yes.
But we're going to be giving you just ordered pairs. And I know that most students would prefer to not have to graph it every single time. And your teachers would also prefer you to not graph it every single time.
Yes.
We want you to use the algebra skills of that slope formula to help you out along the way.
All right, so this is where Mrs. Hograby kept trying to get me to say, and I'm like, I don't know any of this. No, but slopes of parallel lines, and she was exactly right. The whole point of this idea of slope is because there's something unique about parallel lines, and we said that basically, and notice in the postulate, it says in a coordinate plane, two non-vertical lines are parallel if and only if
Ooh, biconditional statement.
they have the same slope. So when you see a biconditional statement, Ms. Hograby, what does that essentially mean?
It means it works both ways.
Okay, so
if I know that they have the same slope, I know that they're parallel. If I know that they're parallel, I know that they have the same slope.
Yes, exactly. Now they said two non-vertical lines. So two vertical lines are also going to be parallel. That's kind of an added thing. And there's a reason. We'll kind of talk about that down here. There's something unique about vertical lines and their slope.
Okay.
That's why they're not really thrown in here. Okay, so if I have parallel, same slope, parallel. So speaking of this idea of vertical lines, slopes of vertical lines. Now I have a little kind of picture over here just for you guys to get a visual. Here's a vertical line. If I counted my rise to run, since it's graphed for us, I need to pick 2 points on the coordinate plane. So let's say these two right here.
Okay.
So what would be my rise to get from one to the next?
My rise is 1.
And what would be my run?
I don't really run at all. My run would be 0.
Oh, you run, Miss Hograby.
Only with you, Mrs. Blairbo.
So 1 over 0. What's going to happen if you simplify that?
That's not okay. You can't ever divide by 0. In fact, I feel like that's almost like a commandment of math. Thou shalt not divide by 0. You can't divide by 0. It's undefined.
So the slope of vertical lines is undefined. So that's why,
Undefined.
if I can spell. Sorry, guys. We're
That's
kind of
funny.
getting corny right now. Undefined. That's why they have this. That's why it said two non-vertical lines are parallel if they have the same slope. Well, undefined is not really an actual value. There's not an actual number to it. So they still will be parallel. We know if you put two vertical lines in a graph, they're never going to intersect. So undefined. Slope of horizontal lines, if I did the same thing and counted, some of you probably already know this. If I pick 2 points on here, what would be my rise?
My rise is 0, but
And
now
my
I run 1
Yes, and that would simplify down to
to 0.
0.
And
So
0 is
this-
a number, so that
0
would,
is a number.
so they're only excluding or putting the non-vertical part because those are the only ones that don't have an actual value.
Exactly.
But notice that there is that kind of extra statement of any two vertical lines are
Yes.
parallel. So
Yes.
they are included. You just can't talk about their
Yes.
slopes being the same.
Something that I like to hit on before we get to one more little piece is because vertical and horizontal lines can be kind of tricky. We're going to be asking you to write equations of lines in just a minute. There's a little phrase that we like to give, and remember that little phrase,
Hoivux.
Hoivux.
And some of you guys may have learned this in middle school. Some of you may not have. So if you haven't, this is a good little recap. Hoivux is just a way to keep track of horizontal
So this is horizontal.
and vertical lines.
So this is saying horizontal, this is saying vertical. Now, what's the next letter?
Okay, the O in a horizontal is actually a 0. It's a slope of
Yeah.
0.
So this is the 0 slope.
And the
this is
U
the-
is the undefined slope.
And what's the last letter?
The last letters to talk about what their equations will look like, which is going to be the most helpful for you
Yes.
as we're writing equations.
I'm going to star that because that's the big one.
Yeah, so the equation in a horizontal line will always be y equals some number.
So this is the equation. Kind of running out of space here, guys. Sorry. And then for this is
X equals some number. So notice that when I just say y equals some number, there's not an X at all in a horizontal line equation. And in a vertical line equation, there is no y at all. You only have that X equals or that
so
y
like
equals.
this line. If you went to this line, what would the equation of this line be?
Well, it's a vertical line, so I'm thinking vux, so it ends with an X. So X equals, and it's over 2, so X equals 2.
And then this one would be
Y equals, and I'm going up 4, so Y equals 4. Now notice that any one of those ordered pairs on this line of X equals 2, every single one of those ordered pairs has that X value of 2. Their Y values are all different, but every X value is 2. So those are just some things you're going to notice.
all of this. Notice some of you are thinking, what does this have to do with parallel? Again, it's all that refresher of writing equations. So a lot of this is Algebra 1 content. We're just kind of reminding you of it. It's been a while since you've dealt with it.
In fact, pretty much everything you're going to do on your homework for these next couple
Yes.
of days, it's going to be a lot of algebra.
So it's horizontal and vertical are a little bit different there. All right, now going into this idea of an equation.
We have several equations that you've learned back in algebra. Ways to write an equation of
Yeah.
a linear equation. So let's think for a minute. What's one thing that you...
I'm thinking the most popular one
Uh-huh.
is called slope-intercept form.
Oh, let me get a new color.
Yeah.
Slope-intercept form. That is a common one that, in fact, since we're talking about slopes, that may be helpful too.
And slope-intercept form is y equals mx plus b. Now, when I think about this form, I'm thinking the m stands for slope
Right?
and the b stands for the y-intercept. And when I do this, I like slope-intercept form is convenient when you know those two things.
Right.
So if you know the slope and you know the y-intercept, you can just substitute those numbers in. You got it. Call it good.
Exactly.
Okay.
We're not always going to be given the y-intercept, though. So there's
Okay.
other forms of linear equations that will also be helpful.
So the
What are
other
some of ones you
one that
remember?
is pretty popular after this is point slope form. And guys, the name kind of gives it away. If you remember, the last one's slope-intercept form. You have the slope and y-intercept. This one's point slope. So you have a point and a slope. Now this one is one that might take a minute for you to remember, but I'll help you out.
Super helpful once you
Okay.
remember it, though.
Y minus y1 equals m times the quantity x minus x1. And in that, the m's still your slope. Now your point is your x1, y1.
Yeah, and notice that it says y minus y1. So that formula is telling you to kind of
Subtract
to
whatever
subtract
that is.
that value. So if it is negative, it will become positive. But yeah, you're going to be doing y minus the y value of that ordered pair. So you're going to be given the point really x1 comma y1.
And,
the slope
and
to be able
again,
to
that
make
one,
this formula.
you would use this if they give you the slope and a point.
Yeah, so depending on what information you're given will depend on what form you can really start in. Now, we could use slope-intercept form to start in and kind of solve for that b. I know a lot of you guys have learned that in Algebra 2. It's another method you can use. I know Mrs. Claremont, I really like that point slope form because
Yeah.
it's really already given that information. We're not solving for anything. But really, either one of those methods work depending on what information
we
you're
might
given.
show both of the ways.
We'll show, yeah. There is one other form that we're really not going to use with this stuff as much, but there is one other form of linear equations.
Standard form.
Standard form.
And
What
this
did that
is
state? Or what was that equation?
ax plus by equals c.
Now, just listening to the names of slope-intercept form, given a slope and an y-intercept, I could write an equation. Point slope form, so given a point and a slope, I can write an equation. standard form. So what, given a standard?
Yeah, it's
there's-
not going to really help us
this
with
is
this.
this isn't one you're going to start with at
Yeah.
least. There may be times where you're asked to put an equation in standard form, but typically what we're going to be looking at, you're going to be given those other pieces and writing those other equations.